All right. I guess this is part 6. Today we're going over disinfection and chlorination. And the title of this one is Purposes of Disinfection. Pathogens may be removed by various treatment processes. Screening, 10 to 20%, which is a physical removal type. Grit removal, which is 10 to 25%, physical removal type. And primary sedimentation, which is 25 to 75% physical removal type. Chemical precipitation, which is 40 to 80%, which is also physical removal type. Trickling filters, 90 to 95% physical removal type. Activated sludge is 90 to 98% physical removal type. And then we reach chlorination, which is 98 to 99%, but it's the only disinfection type, at least listed here. Other disinfection treatment processes is UV light, ozonization, and sterilization. Chlorination. Chlorine and its various forms are powerful oxidants that will kill or inactivate most pathogenic organisms that are harmful to humans and animal life. Chlorination is the most commonly used disinfection process for wastewater. Chlorination chemicals are relatively easy to obtain, economical, effective, and easy to apply. Typical forms of chlorination used in wastewater treatment are elemental chlorine, hypochlorite, and chlorine dioxide. Elemental chlorine, also known as Cl2. Elemental chlorine is either liquid or gaseous in form. Chlorine gas can be compressed to a point where it liquefies. Cylinders contain both liquid chlorine, approximately 85%, and gas chlorine, approximately 15%. Elemental chlorine is provided in liquid form and delivered in 150-pound cylinders and 1-ton canisters for very large plants. It may be delivered in tank cars. Its concentration is 100% available chlorine. Chlorine generally evaporates within its container and remains in a gaseous form. It is mixed with water prior to being introduced to the process flow stream. Under high demands, it may be removed from containers in liquid form and gasified in an evaporator prior to mixing with water. Liquid chlorine is clear or amber-colored liquid. Liquid chlorine rapidly vaporizes to gas when unpressurized. 1 volume of liquid yields approximately 460 volumes of gas. Leaking cylinder emergency tip. If you determine you have a leak in your chlorine gas cylinder, position the cylinder so that the leak is on top to release the gas rather than the liquid chlorine. For example, if the leak is in the fusible plug, roll the ton canister so the plug is in the upmost position. Gaseous chlorine is a greenish-yellow toxic gas. In its gaseous form, it is approximately 2.5 times heavier than air. Chlorine gas, free chlorine, reacts with water to form hypochlorous and hydrochloric acids. Chlorine plus water equals hydrofluoric acid, or hypochlorous acid, and hydrochloric acid. In solutions that are diluted and have a pH above 4, the formation of HOCI, hydrochlorous acid, is most complete and leaves little Cl2 existing. The hypochlorous acid is a weak acid and is very poorly dissociated at levels below 6 pH. Thus, any free chlorine or hydrochlorite ions, OCI-, added to the water will immediately form either HOCl or OCl-. And what will be formed is controlled by a pH valve of the water. This is extremely important since HOCl and OCI, it's I, not L, differ in disinfection ability. HOCI has a greater disinfection potential than OCI. Normally, the wastewater with a pH of 7.3 depends on the temperature. 50% of the chlorine present will be in the form of HOCI and 50% in the form of OCI. A higher pH level will result in a greater percent of OCI. And this is a chart that shows the distribution of HOCI and OCI- in the water. Okay. Disinfectants and chemistry. Hypochlorite, OCI-. Hypochlorite may be provided in several forms. Sodium hypochlorite. It is acquired as a liquid in the form of sodium hypochlorite, NaOCI, which is bleach. It may be obtained in carboys or in bulk delivery in this form. In this form, it is available in concentrations of 12.5% and 15%. This is the general form of hypochlorite or bleach used in most wastewater treatment plants. It may also be generated on site from the electrolysis of salt, NaCl. In this form, it is available in concentrations of approximately 0.7% to 0.9%. Sodium hypochlorite, or bleach, reacts with water to form hypochlorous acid and sodium hydroxide. Calcium hypochlorite. This chemical is available in granules, pellets, and powder. It may be delivered in cans, barrels, and drums. It must be mixed with water prior to its use. Concentrations may be prepared with a 3% available chlorine. This chemical is also known as high-test hypochlorite. So calcium hypochlorite is also known as HTH. So HTH contains a high concentration of chlorine, typically 65 to 70%. The rest is calcium. Okay, chlorine dioxide, or CiO2. Chlorine dioxide is a relatively unstable chemical and is manufactured at its point of use and introduced into the flow stream shortly thereafter. Chlorine dioxide is the result of a reaction between chlorine gas and water solutions and sodium chlorite. The reaction under controlled conditions will result in a 2% solution having a theoretical available chlorine content of 26.1%. Due to its initial reaction with reducing agents generally found in wastewater, its strength as a disinfectant is greatly reduced. It is beneficial to use this form of disinfectant when the pH level of the treated water is above 8.5. So you want to use chlorine dioxide when the pH is above 8.5, so where it's more alkaline. Chlorine demand. Chlorine will react with wastewater and combine with many of its components. These components react and combine with chlorine prior to its reaction with pathogens. The demand by inorganic and organic materials is referred to as chlorine demand. It is the difference between the amount of chlorine applied to wastewater and the amount of residual chlorine after a given contact time. Inorganic materials commonly found in wastewater that take precedence when reacting with chlorine are hydrogen sulfide, ferrous iron, manganese, and nitrate. All of those will react first with the chlorine before your water. Ammonia, or NH3, is found in all wastewaters and is the second level of reaction with chlorine. It combines with chlorine to form one of three forms of chloramine. Chloramines act as a disinfectant, and the three forms are monochloramine, dichloramine, and trichloramine. Okay, so monochloramine, one chloramine, dichloramine, two chloramines, trichloramines, three chloramines. Organic compounds are the last to react with available chlorine in wastewater and form chlorogenic compounds. These have a slight disinfection capability. Chlorine residual. The chlorine in combined forms that have disinfecting properties plus any free chlorine is the chlorine residual. It is the component of the applied chlorine that is available for disinfection. The residual is available in three forms. Chloramines, a form of combined chlorine. Chlorogenic compounds, a weak form of combined chlorines. And free chlorine, the strongest form of residual for disinfection. The sum of the chlorine demand and the chlorine residual is the chlorine dose. Okay, so chlorine dose is equal to the chlorine demand plus the chlorine residual. The chlorine residual is equal to the combined chlorine forms plus free chlorine. You can also rearrange the equation to chlorine demand is equal to chlorine dose minus chlorine residual. Establishing dosages. Chlorine dosage may be established from either bench scale laboratory testing or an actual measurement of the field results from known plant operations. The results are suitable for establishing based feed rates. However, real-time corrections must be made to adjust for changing conditions. Since field conditions are not as controlled as laboratory tests, the actual dosage will generally be higher than those established in the laboratory. Factors influencing disinfection. In addition to chlorine residual, there are a number of factors that influence the efficiency of the disinfection process. The proper point of injection to flow stream and thorough mixing is essential for full treatment. Once chlorine is injected into the flow stream and mixed, the flow then goes into the chlorine contact basin. This is a tank designed to provide adequate detention time or contact time to assure thorough reaction of chlorine to pathogens. The chlorine contact basin design is of critical importance to maximize the detention time through the basin and minimize short circuiting. Bathing within the basins helps minimize short-circuiting and aids in mixing. Note that the length to width ratio is 40 to 1, and that the unit is generally designed to provide 30 minutes of contact time at maximum month average flow, or 15 minutes of contact time at peak hourly flow. Effective pre-treatment will lower the suspended solids and organic contents of the wastewater stream, which allows the disinfectant to be more effective at reducing pathogens.